Hello grade 7 students. Today we will start with a new chapter, chapter 4, Activities and Energy Expenditure, Worksheet 24. At the end of this video, you will be able to identify that an increase in physical activity leads to an increase in the consumption of food and oxygen. Note that the body's energy is produced mainly by the energy of the food consumed, carbohydrates and lipids. Materials needed: a pencil, your calculator, and your biology worksheet booklet. What are the main vital processes for the body? What do you need to stay alive? We need to breathe in order to ensure oxygen and to eat to ensure our nourishment. In this video, we will discuss the effect of physical activity on breathing and eating. Why are these processes important? Do they vary with the physical activity done by man? Now, open your worksheet booklet on page 36 and follow with me in worksheet 24. The first problem posed is: how does physical activity affect human oxygen requirements? Is there a relationship between physical activity and human oxygen requirements? If yes, what is this relationship? Try to formulate your hypothesis and remember that the hypothesis is an answer or prediction to the posed problem. Did you write your hypothesis? Very well. We can say as hypothesis, when physical activity increases, humans' need for oxygen increases. We are going to do an experiment. We will calculate the respiratory frequency in each of the cases mentioned in the table of your worksheet booklet. First, reminder, respiratory frequency is the number of respiratory movements per minute. So now, count the number of respiratory movements, the number of inhalation and exhalation, in 1 minute in each case mentioned in the table of page 36. In the first case, while you are sitting, the second case, while you are walking, and in the third case, while you are jumping. So, as you see, the respiratory frequency while you are sitting as an average is equal to 16, while walking is equal to 25, and while jumping is equal to 36. Now, let's read number 1. Find the relationship between the difficulty of physical activity and the respiratory frequency. How can we establish a relationship? We can establish a relationship when we relate the variation of two factors. How does the respiratory frequency vary with physical activity? Going from sitting position to walking, then jumping, you can notice that the activity becomes a little more difficult and that the respiratory frequency increases. So the answer should be as: when the difficulty of physical activity increases, the respiratory frequency also increases. This graph shows the relationship between physical activity and oxygen consumption. So on the y-axis we have the quantity of consumed oxygen, which is the responding or the affected variable, and on the x-axis we have time, which is the manipulated variable in minutes. First, before the exercise, then during exercise, then after exercise. As you can see here, before the exercise, the quantity of consumed oxygen remains constant, while during the exercise, the quantity of consumed oxygen, first of all, it increases, then it stays constant, while after the exercise, the quantity of consumed oxygen, first it decreases, then it stays constant. Now, let's analyze this graph. Analysis of this graph. First of all, we should take into consideration the responding variable, which is the quantity of consumed oxygen, and we should always talk about it. We are interested in seeing the variation of the responding variable while we are changing the time. So first of all, we start with the first point, which is 0.25 liter per minute. We should say that before exercise, the quantity of oxygen is 0.25 liter per minute at time 0 minutes. Then what happens? This quantity, as you can see, remains constant at 0.25 liter per minute when the time, what happens to the time, increases to 2 minutes. Then what happens to the quantity of consumed oxygen? Then this quantity increases IMTA during exercise to reach a maximum of 1.25 liter per minute when the time also increases to be 4 minutes. Then what happens to the quantity of consumed oxygen during the exercise? Then it remains constant at 1.25 liter per minute when the time increases to be 8 minutes. Then let's see what happens to the quantity of consumed oxygen after the exercise. Then it decreases to 0.25 liter per minute, means it returns to its initial value when the time was at 0. After the exercise, when the time increases to 12 minutes, then it remains constant at this value 0.5 liter per minute as time increases to 16 minutes. Number 3, give the relationship between the quantity of oxygen consumed and the exerted physical effort. So as you can see from the graph, we have seen that the quantity of O2 increases with effort because the respiratory frequency increases and consequently the quantity of O2 entering the body will increase. So when the exerted physical effort increases, the amount of oxygen consumed also increases. So here, this person is at rest, the consumption of oxygen is normally, but when he increases his effort with high intensity, the quantity of consumed oxygen will increase. Now, problem 2 that we are going to study now is how does a physical activity affect the need for food in man? So we can pause the video, try to answer this problem by formulating a convenient hypothesis. So the hypothesis for this problem can be as when the physical activity increases, the need for food in man increases. Consider the following table. The consumed food, different consumed food outside the training period and during the training period. Training period means during physical activity, means during making sport. So the consumed food outside the training period without doing physical activity, meat and egg fish was 150 gram, milk cheese 350 gram, butter, oil, margarine 40 gram, potatoes, bread, rice 400 gram, vegetables, fresh fruits 500 gram, and sweet products 70 gram. While the consumed food during the training period, while we are doing exercise, meat, egg, fish were 300 gram, milk, cheese 470 gram, butter, oil, margarine 65 gram, potatoes, bread, rice 730 gram, vegetables, fresh fruits 800 gram, and sweet products 1000 grams. As you can see here, the consumed food during the training period increases. So number 4, calculate the total mass of consumed food during the two periods. So now hold your calculator in order to calculate the total mass consumed outside the training period. So let's now add all the consumed food during or outside the training period to have a number of 1150 grams. And now let's calculate the consumed food during the training period by adding all the food together to have a number of 3365 grams. Number 5. Compare the total mass of food consumed during and outside the training period. So when we want to compare, we should first of all mention the values with their units, and we should say either greater than or less than or equal to. So we say that the total mass of food consumed outside the training period is 1150 grams, less than the total mass of food consumed outside the training period, which is 3365 grams. So the total mass of food consumed outside the training period is 1150 grams, smaller than that during the training period, which is 3365 grams. Draw out a conclusion. Our conclusion should depend on the comparison that we did in number 5. So our conclusion is the amount of food consumed increases during the training period. Number 7 now. Establish the relationship between the need of food and the physical activity. So as you can see here, at rest, the need of food is very low. Then when he made effort of low intensity, the need of food increases from very low to somehow higher. Then when he did more effort with higher intensity, it increases to be the highest. So we can give a relationship as when the physical activity increases, the food consumption also increases. What do we need to carry out our daily activities? In order to think, in order to walk, in order to write, we need energy to do all our activities. Let's go to see where the energy comes from in man. So the food we eat provides us with energy. The production of energy takes place inside every cell of our body. Each cell uses O2 from respiration and food from nutrients to produce energy which is necessary for any action done by any organism. Do all food have the same energy value? Before answering this question, we must classify the consumed food into food rich in proteins such as milk, meat, and eggs, food rich in lipids such as oil and butter, and food rich in carbohydrates such as bread, rice, potato, and pasta. Let us examine this table which shows the energy released in kilojoule for each type of food. The energy released from proteins is 17 kilojoule, the energy released from lipids is 38 kilojoule, and the energy released from carbohydrates is 17 kilojoule. So we can conclude that not all food can supply us with the same amount of energy. Number 8. What is the most energetic food which produces the greatest energy? So as you can see here, the most energetic food is the one that gives 38 kilojoule, which is lipids. So first, let us know what's the meaning of kilojoule. Kilojoule is one of the units of energy. So lipids are the most energetic foods, 38 kilojoule. Number 9. Rank these foods in decreasing order of their energy production. Decreasing order means from the highest food that gives energy to the lowest food that gives energy. So the highest food that gives energy is the lipids, which is 38 kilojoule, then the carbohydrates, which is 17 kilojoule, and which is equal to it, proteins, also 17 kilojoule. Now, let's solve together this application. Answer by true or false and correct the false statement or statement. So let's start with part A. The needs of food for an athlete are greater than for a sedentary person. Sedentary person, a person that always is at rest. So sure, the answer should be true. Part B now, the consumption of oxygen decreases with the physical effort. Unfortunately, it's false. Oxygen consumption increases with the physical activity, as we said in the previous slides. Part C, the more difficult the physical activity, the more the nutritional needs decrease. Unfortunately, it's false because the more difficult the physical activity, as we said, the more nutritional needs increase. Part D now. Carbohydrates have the greatest energy value. Unfortunately, it's false. Fat or lipids has the greatest energy value. Another application, number 2, complete the following sentences with the appropriate word. The main function of food is the production of, yes, energy. Great. Part B now. When physical activity increases, the respiratory frequency, great, also increases. The oxygen consumption also increases, and the need for food also increases. Part C now. The organic foods consumed can be classified as carbohydrates, lipids, and proteins. Great. So, as a summary, the consumption of oxygen and food increases during the physical activity. The organic food consumed can be classified into lipids, carbohydrates, and proteins. The main role of food is to produce energy. Lipids are the most energetic food. As a homework, underline the two sentences which are in bold in page 37 and memorize